to a square, then we went to a parallelogram, then we did a rhombus, then we did a trapezoid. We're going to do a sixth one.
Was that geometry?
Quadrilateral. Quad meaning how many sides?
4.
We're going to do the isosceles trapezoid.
You keep me from 6th period, yeah? 6th period. Yes? Okay.
I can never spell isosceles. ISOSCELES. Isosceles trapezoid. Isosceles trapezoid. The purple is not the same size as the pink one. It does. Are yours the same size?
Almost. Yeah. It just doesn't. Oh. They just cut it.
Mine has the slightest difference.
I'm curious. It's off. It's not quite 3. I think so. By 2.
I think she needs to get
Well. Yeah, that's why I said you gotta be careful. Yeah. That's why I was like, let me try to do cut 2. Who got the pink? You? The pink's right. This one is not. It's okay. Alright, we'll just pretend it is. It's gonna bug me, but okay. What we're going to do here, we're going to make our isosceles trapezoid. Isosceles is a key word. Most of us probably do not know what isosceles means.
Isn't that one triangle we did?
Maybe. We're going to do the same thing as we did the other day. We're going to take the corner and we're going to make a line up to the other opposite side.
the one with 2 sides.
I don't know. Yeah. Then go ahead and cut it. This time we're not throwing it away. So we just cut it, looks like this, right? All right, ready? If you've already cut it, you're going to take it to the other side, but you need to flip it. Okay? You good? Question? Looks like this. Jonathan, head off your head, please. All right. Isosceles was the key word here. Isosceles means something special. Isosceles means you have 2 congruent sides. Base angles are also congruent. So you may have done it in 6th grade, according to some of you. Maybe not. We'll draw the triangle. It's not equilateral, okay? But it looked like this. You knew this was congruent to this. So your 2 sides were congruent, and your base angles had to be congruent. Those are the bottom. So this was for an isosceles triangle. An isosceles trapezoid still has 2 sides congruent. Which sides are going to be congruent? The top and the bottom?
No, the side.
No, the slant, right? They're called legs. So these will be congruent. And then what else? These are congruent. Where are the angles congruent? At the bottom. Why the bottom? Because it's the base. Okay, it's the base. Good? I really poked, bless you. I poked my eye and it hurts, you guys. Was it a cough? Did you say it was a sneeze or a cough? Oh. Don't you hate that? You know what's the worst is when you have to sneeze really badly and you're driving and then you sneeze really hard and then you're like trying not to like crash at the same time. That sucks. Or not. Or not. Who said that?
What'd you say? I can see you do it.
Alright, on this one, diagonals are congruent. Base angles are congruent. Do the rules still count from yesterday's trapezoid? Do we still have one pair of sides parallel? Yes, we do. Oh, yesterday too, I think I put a 2 here. It's supposed to be a 1. I was going to say 2 angles, but it should be 1 pair of angles. I don't know if I wrote a 2 there. Yeah, fix it to a 1. It's only 1 pair of angles that are right angles on this one. I accidentally put a 2. I'm going to just say 2 angles, and instead I wrote 2 pairs. Okay? All right, back to the bottom. And flip it over. We're also going to say that legs are congruent. Leg here, and a leg here. Okay. And lastly, our formula. Do you think our formula is going to change for area? No, it's the same. Area is equal to height times what? Base 1. Plus base 2 all over 2. Very good. When you're done with that, you can go ahead and put it in. Matthew, where did you go to in and out? Or did someone bring you in and out? Did someone bring you in and out? Oh, okay. But it's far. It's not close. Let me look this one up. All right, ready? I'm going to go to the next page.
What if we could fit it?
Then squeeze it in. I'm going to still add in something after, so. Give me a second. Don't play with the scissors. Give me a second, guys. Mr. Lopez, the next one's half and half, right? The last one?
Yeah.
It's half and half?
I think a piece of it.
Oh, piece of it. That's what it is. Thank you. Couldn't remember. Okay. Ready? Okay, take the next one. You didn't get one? Where'd you get another one? You didn't get one? No. Fold in half.
Oh, like that.
Yo, I just saw that pig. That's cool. Come on.
Who else doesn't have? I feel like Mr. Lopez counted correctly. No? Okay. Well, they didn't have like a hot dog, burrito, taquito, whatever you want to eat.
Wait, what? Tequila? Is that what you said?
No.
You said tequila.
You said taquito.
What's a taquito? What's a taquito? I did.
How do you explain it like very easy? It's like a rolled taco that's fried.
Oh, the one at 7-Eleven?
If you're eating food from 7-Eleven.
No. Did
They
you?
have the little taquitos.
Dude, those little roll-up chips.
Like an egg roll.
Those are taquitos.
It's like an egg roll, but not an egg roll. Alright, I'll be out here.
Mexican egg roll.
Yeah, not really, but okay. Here we go.
But it is.
Listen very carefully. Ready? Shh, you're gonna fold. When you make this fold, you cannot fold to the halfway mark. You're just gonna fold a piece. Just fold a piece. Oh, I should have folded that more. It's alright. It works.
How big is the piece supposed to be folded?
Just at the half. Not to the half. Keyword, not. Quarter of the way? That works.
Quarter? Oh, no, like 27th of a quarter.
You guys should try my niece's homework one day.
Too easy.
What happened?
He said, bro, I can't do it.
It was fun, let me just tell you. Ready? Open. From this point here, do you see the fold? Do you see how this is the open flap?
Yeah.
Okay, I'm going to connect from my fold to the corner, from this fold to this corner.
That's a possibility.
Make it a star.
Explain again.
From there to there.
Wait, can you get the area of the star? Oh, alright, I got you. Oh, wait, we're just making it.
And then from here to here.
Okay, you should have said
I said connect. Thank you, Sebastian. I never said fold. I never said fold. I said connect.
No, you said fold.
No, I said from the fold. There's a difference in my language. Make sure that this is the part that opens. Yes, Jaime. Fold it there. Do you see that?
Now we're making a kite.
This is the part that opens. Then you can cut it. Cut. And then you have this. Yes. Yes.
Look at it's a diamond.
No, I just had them in the same order. Did you do yours backwards? Good job. It doesn't shock me. This is why I gave one color at a time.
Shocks me.
I said purple earlier. Yours is going to look a little differently depending where you fold it. As long as you didn't fold the middle, we're good. Mr. Lopez's looks a little different than mine. This is what his look like. Mine looks like that. Yours is fine. It works. It still works, I promise. It still works. It still works.
It looks like a diamond.
no, it's like a kite.
It is a kite.
It's like a diamond.
I should give you that extra credit project. You have to actually make a kite. And then it has to fly.
Yeah, can we do that? For extra credits?
Hey, out of sticks.
Yeah, you have to. Like, you cannot buy one. You have to make it.
Exactly, that's how I made it.
Wait, so we'll do it?
Hey, wait.
And then it has to fly.
Okay, I'll do it.
I'll do it.
We'll see.
Wait,
What time do we have to bring it in by?
Oh, Lord. I have to, like, write the thing up. I have to find the project. I have to find the project. Does it matter? Because guess when you get extra credit in my class?
Never.
Okay.
Oh, we don't?
Hey, how about that soap?
You got that extra credit, but that's about
It's
it.
a shame.
Extra credit doesn't do anything to your grade unless you have no homework in. Then it helps you. All right. It kind of gives you a little buffer in your grade is what it does.
So I'm just gonna, like, do it for fun.
It gives you a buffer in your grade. Because like some people right now had like an A in their homework and then I put in their test and now they have a B. So it just buffers your grade. All right, let's do this. Okay. What do you notice about your diagonals right here in the middle?
Bisect.
They don't bisect. Bisect means to what? Cut in half. They're not cutting in half. They are intersecting. They're perpendicular. Very good. What's the symbol for perpendicular? Upside down T. Very good. So there's your perpendicular right there. Yes? You see them? Okay. One pair of opposite angles are congruent. Does anyone want to take a guess which angles are congruent? Are those actual glasses? Yeah. Oh, they're cute. Which ones? Yes, these are your congruent angles.
Wow.
Because they're connected. When you connect them. Yeah, they line up when you connect them.
Okay.
Look like this.
Like, if you fold it in half, like that.
Yeah, because we're folding in half, they're right on top of each other. Yes, there you go. All right, we good? Let's flip it over to the other side. I need a rectangle. Let's see. Ouch. What color was that? Pink? Purple. It's pink. I'm going to pick a different color. Hopefully this one works. This works. For the most part. Oh, yeah, you can't. That's weird.
See? Mr. Sanders, that's where I got my keys. I didn't let you do it.
That's why. All right, listen up. Shh. Pay attention. We're going to figure out the area formula. You ready?
We can make another kite with the other one.
Oh, you can. You can make another kite with the other. Hey, why are we talking over there? Stop it. You can make another kite with the other two. Pretend they're exactly the same length. This one's off just a smidgen. What else do you notice? What's this? The same height. And what's this? The same base, right? And what is this called, though? This isn't a base, a height. This is the what? What does it start with? Starts with the D. It's a diagonal, and this is a diagonal. So A equals diagonal 1 times diagonal 2 divided by what? 2. Why 2?
Because it's a triangle.
You can still make 2 kites. Stop talking about triangle. You can make 2 kites. If you notice, this piece will probably end up exactly where? On top of here. And this piece will end up on top of here. These 2 pieces are exactly the same as this, right? Now remember, which other quadrilateral had the same area? We did it.
Rhombus.
A rhombus, good.
Yeah.
And the rhombus is which one?
Blue one.
It looks like a, I don't like the word diamond,
Slanted.
slanted square.
Damn, it does. 3D.
Okay, hold on. Shh, stop talking. You are going to add another thing into your notes. You're probably going to want to glue it. So that piece of tape you can just use all the way in if you want. Okay?
Yeah.
Okay, over here when you stop talking, because there's way too much talking. And then I get test grades, and then it makes perfect sense.
Are we going to be able to test grades?
Possibly. Depends how long this takes me. I don't know how many that is. That should be enough. All right, we're going to do this. Cut off the edges if you want. You're going to make it fit in your notes. So all I'm doing now is I'm taking all of the properties and we have this flow chart. This is called the flow chart because it has arrows. Do you see the arrows? Okay. Was it perfect? Oh, that's pretty impressed. Lost my glue. There it is. Hey, shh. I want to get through this so you can solve homework. Time, because guess what you have tomorrow? A quiz. Yes, I'm for real. Okay, let me tell you what's on your quiz while you're currently gluing in your paper. Your quiz tomorrow consists of parallel lines. It consists of parallelograms. It has quadrilaterals, as in by naming the quadrilateral. And then it also has a proof. There's only one proof. And it's not a start from finish. It's kind of where you have to fill in the blanks, okay? The review didn't have a proof. Nope.
Wait, so we're gonna have parallel?
Parallel what? Parallel lines.
Oh.
Parallelograms. And
Quadrilateral.
naming the quadrilateral.
Oh, naming them.
All you have to do is name the quadrilateral.
Okay, I'm studying all day today.
I suggest you know the difference between, you need to know the words in a stop it. In a parallel lines, you need to know the words. So what I mean by words, I mean consecutive what?
Oh, that's all we need to do. Name them?
Not just name them, sir. You also have to solve. What do you think the whole point of this unit is? Okay?
This is not math. This is,
This is actually the most real life math, like that you will use more often than not. You will learn that your walls in your house, I guarantee, are not in right angles.
They are rhombuses.
Pretty much. Exactly. They are not very straight. Guaranteed. They all are. I guarantee your house is not very straight.
bet it is.
I bet you it's not. My dad put in my brand new cabinets. Perfectly pretty box. Went to put on the wall, and you can see like a big gap. So what did he do with the cabinet? Well, this is what he does for a living. He like sawed it in like pieces and like stuck it back up there. So like it's missing, like in the back of your take it off, it's like missing pieces. Yeah, that's what they do when they put your cabinets up. Yeah, if they don't, because your walls aren't straight.
Oh, we're not cutting everything.
All right, ready?
No.
Oh my God, I'm starting because it took you 15 minutes to cut a piece of paper. All right.
Wait.
Quadrilaterals, here we go. You're under the umbrella of quadrilaterals. Do you understand? So what it's saying is this. If you're a quadrilateral, you can be a parallelogram. Got it? Under the umbrella of parallelogram, you're a parallelogram. You can also be a rhombus. Do you understand? So is a rhombus a parallelogram? Yes. But is a parallelogram a rhombus? No, not necessarily. Do you understand? Stop talking. Under parallelogram, then you can also be a rectangle. But are a rhombus and rectangle the same? No. Are they both considered a parallelogram? Yes. Do you see how the flowchart works? Then under both rectangle and rhombus, you are a square. Got it? Do you see how this works? Now, if I look here, I see a kite. A kite is completely all by itself. It does not have anything to do with a parallelogram over here in this umbrella. When I look here, I see trapezoid. Underneath trapezoid, I then see isosceles trapezoid. Got it? Do you see how the flowchart works? Okay. We're going to go ahead and we're going to make the markings in a parallelogram. So, looking at a parallelogram's characteristics, what do you know about it? Congruent what? Congruent sides. For congruent sides today, I'm going to use a highlighter. Do you hear me? So you might want to make a note. Would I highlight to be congruent? Those are congruent. Yes? What else is congruent? Top and bottom. Sarah, why are you talking? No. So we have congruent sides and they are highlighted. Shh. TJ, why are you talking? I want to get through these notes. I have 25 minutes and they should not take me more than 10 to 15. And with you guys talking, that means you need new seats. Alright, so here's our parallelogram. You know opposite sides are congruent. What else do we know about a parallelogram? What makes it a parallelogram? Parallel lines where? Opposite sides. So how do I know it's parallel? What symbol? The two triangles. These are parallel. What else is parallel? The sides are also parallel. Okay, what else do I know? Congruent angles are where? Opposite. So if I mark this one congruent, opposite of that is over here, correct? Which means this one's congruent to this one. Yes? All right, what else? What are you missing?
The line.
What are those lines called? Diagonals. Diagonals do what? No, they bisect. Let's use the right words. Bisect. Oops. I can't draw straight lines.
Ooh, I get it now.
Okay, good. Get it quietly. Bisect means that this one is congruent to this one and this is congruent to this. Yes? Anything else? Alright, from a parallelogram, which way do you want to go? Rectangle, wonderful. What do you know about a rectangle? It has parallel lines where? Opposite sides are parallel. So this is once again parallel here. And this is parallel here. What else do we know? All the angles are congruent. Why? They're all right angles. Very good. So I'm going to make them all right angles to know they're all congruent. What else do I know? Congruent sides are where? Top and bottom, or, so what's the correct word? Starts with an O. Opposite sides are congruent, so I'm going to highlight those. Do you have all this information already? Yep. What else? The diagonals do what? They bisect. Anthony, what are you guys doing?
Pressing the crib one.
TJ, you're not funny right now.
Oh, just saying.
No. What do diagonals do? I forgot. Bisect. Good? What else? What else do diagonals do?
What you say?
Oops. I don't even know what that is. Oh, it should have been the same. I should only have one line. They're congruent. So technically it's congruent. Because it says diagonals are congruent, yes? Do you see them? So technically, they're all the same. Where do you want to go next?
Go square.
Okay, let's go square. What do we know about a square? All the sides are what? Congruent, so they all get the same what? Color. What else do we know about a square? All angles are 90 degrees, which means they're congruent. Good. What else? The sides are right here. Well, that's what we highlighted. I heard it, I think. What? What's parallel? Which sides? Opposite sides. All right, opposite sides are parallel. All sides are congruent. All angles are congruent. What else? Diagonals bisect, and they also form what? Perpendicular. So if they're perpendicular, then there's a right angle in the middle as well. And diagonals also do what? What does it mean to bisect? Are they congruent to each other? Yeah. What do the diagonals do to your angles? What do diagonals do to your angles? Nothing? What do diagonals do to your angles? Did we talk about it? I think I did. No? All right, it's a square. So since this is a square and these are bisecting, yes? I get to cut these. These are 90 degrees. This cuts it in half. So this is congruent to this, and 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 to this. Means when we cut it, all angles are 45 degrees when diagonals bisect. Degrees when diagonals bisect. This right here is going to be important in a couple weeks. It's a special triangle. Literally. Okay? So then we go to a rhombus. What about a rhombus? Which ones? Opposite sides are parallel. What else? What about your sides? Opposite sides are congruent or all sides are congruent? It's up being all sides. This page is tilted. Oops. Okay, what else? Which ones? Opposites. What else? You're missing what? Diagonals, what do your diagonals do? They bisect. Oops, someone's not open. What else do your diagonals do? Form a 90 degree. Which makes them what? Perpendicular. All right, back to the umbrella of quadrilaterals. Where do you want to go, kite or trapezoid? Kite. All right, what do you know about a kite? Diagonals are perpendicular, so let's draw those in. Okay. What else? There's one pair of opposite angles that are congruent, so I'm going to mark those. There's that one and that one, right? We didn't talk about it, but what do you notice when I fold this in half? Besides that. What do you know about it? It's not isosceles because we don't have two congruent sides. It's what? It is scaling. What else do you notice? What do I notice about this side? What about this side? Are they the exact same? So that means they're what? What do you know about the bottom? They're also congruent to each other. Okay? All right, trapezoid, what do you know? How many sides are parallel? Just the bases, very good. Does this one have anything congruent? No, it doesn't. No sides are congruent, sorry. No sides are congruent. But you do have two what? Two right angles. Is there anything else in this one? That's it. It's kind of boring. Okay, isosceles triangle. What do you know about an isosceles triangle? I mean trapezoid. You guys got me saying triangle. Bases are parallel. Thanks. What else? What makes it isosceles? Two congruent what? Sides, which is the legs. Very good. What else? Diagonals are congruent? No, just kidding. I forgot I wrote that. All right, what else? I'm missing something. Starts with a B. Base what? Base what? Well, not the bases are congruent. The base what are congruent? I don't know. I'm just playing with the ruler over there. Base what? Nope. Your base angles. Your base angles are congruent. Just like in the triangle. Yes. Which makes these congruent. Because either way, they're both bases, yes? My eye still hurts. Good? Guess what? Summary. I'm done teaching. Your job, I don't care where it's at. You should be on the third page, right? So you should probably have a summary on the back of that third page, so page 4, or I don't know how much room you have at the bottom of that page, but it shouldn't be slanted